So 11-7, as mentioned, probably the last bunch of formulas you're going to have to put on in your formula sheet if you have it. But notice today we're not going to talk about, say, surface area about just separately and then volume just separately. We're going to talk about them both at the same time. So for total area, again, we don't have any lateral area for a sphere. I hope you can kind of visualize that it doesn't have just stuff that goes up. So we are finding total area, or sometimes we call it surface area, is just 4 times pi times the radius squared. And then as you notice, that will actually make your units squared. That'll be perfect. And then for volume, it is 4/3 pi r cubed, which will then make the units cubed. Right? So definitely a calculator is going to be very helpful because it does have the pi button on it. And I'll probably show you how to deal with the 4/3 for those of you maybe that have the TI-83s or something like that. You kind of have to deal with the 4/3 a little bit differently. So here it says the diameter of a softball is approximately 3.5 inches. Okay. Determine the surface area. Please realize that means from the center of this softball, pretty much out in any direction, right, is going to be 3.5. Determine the surface area. Well, that would be that formula, correct? Are these separate? No, they're together. All right. So 4 pi r squared. Not sure what that is, but we'll just save it like that. That was pretty good for first day back in a while. That's a good save. So we got to take 4 times pi, which again is a number on your calculator, and a Greek letter. And we have to take, well, do we know radius? Well, sorry, the diameter is all the way across, so boy, 3.5 all the way across the softball. You think that's accurate? That's pretty close. Well, what's radius then? 1.75, right? Boy, I'm off to a really good start today. There we go. And that's inches, which I have to square. So why don't you go ahead and, now again, you have to read. Does it say exact or does it say rounded? You'll have to read into that and see how it does that. But go ahead and try that. So I'm going to write it over here and I'll go to the calculator. 4 pi 1.75 squared. And the nice thing is with the calculators, especially the TI-83s, you can pretty much just write it as I see it right there. So I can just go 4 pi and then just put a parentheses, what I would do, 1.75, and then squared. Okay? And that should do it for me because it knows order of operations. So what's it going to do first? Yeah, it's going to do the parentheses, and it's going to then square it, correct? And then it'll take 4 times pi and then times that answer. Again, it'll do it for me, which is kind of nice. And so we would have to watch. Do they want me to round it? Do they not want me to round it? I would say they probably would, and we'll say nearest tenth. How about that? So 38.5. Okay. So apparently this comes out to, what was it, 38 approximately, right? 0.5. Yeah, and again, truly it is inches squared. I'm really trying to get this into your head because we took inches and we squared it. Okay, so inches squared. Again, if you have different labels, yeah, you don't want feet inches or something like that. You got to get them the same so that it comes out this way. Any questions on that one? Pretty straightforward, really. Okay. This is actually one of the pictures I'm more proud of because I had to make that. It took quite a while. It ended up pretty good. And that was back when I was just learning how to use it, so I could probably do it a lot quicker today, but that took some time. I'm sure you've all seen a sleeve of golf balls before, correct? Do the golf balls take up the entire inside of that box? No, there's a lot of air in there, correct? And because obviously the golf balls do touch. There's a little wiggle room in there, but not a lot. And so we're going to determine the volume of empty space, so the volume of the air in there. So obviously we got to figure out the volume of that. Well, what would the box be called? Just itself. What if the box was completely empty? What would that be called? A prism, right? A rectangular or square prism, right? And so we're going to find the volume of that, and then we'll subtract out the volume of 3 golf balls. Will that tell me how much is left over? Yeah, well, let's do that. So it says the box is what? 4.8 inches tall, square base, that's 1.5 by 1.5. And the diameter of each golf ball is approximately 1.5 because anybody that's done that, they do fit in pretty snug, right? And so, well, volume, well then you better take a look at your formula sheet and figure out how you take the volume of a prism because we're going to do the box first. How do you find the volume of a prism? Yeah, pretty much area of the base times the height. So for us, our base is basically just a square, right? 1.5 by 1.5. And to find an area of that base, you would just take 1.5 times 1.5, right? Well, what is 1.5 times 1.5? I think I heard somebody say it. 2.25. So that's right here, and that would be inches squared, correct? That's the area of the base. Now we have to put the height, again, the height of the prism. Not the height concerning with the base, but the height of the prism, which is 4.5, and that is also inches. So we take 2.25. Do I have to square the 2.25 or anything like that? I see the square in there. No, that's for inches squared, right? And then you take it times 4.5. What is it? 10.125. And that's going to be inches cubed. Is that the answer to the question? That would be the answer to the question if there were no golf balls in there, right? But there are. There's 3. So that's how much empty space there would be if there were no golf balls. So we better turn around then and find out, well, how much would there be if there were golf? So in green up here, we will do the golf ball, and that formula is 4/3 pi r cubed. And again, I'll probably take you to the calculator here in a second and show you, the best way, especially on the TID3, to deal with that 4/3. So 4/3 pi, well, it says the diameter is 1.5. What's the radius then? 0.75, okay. Which I have to, unfortunately, take to the, not second, but 3rd power. Okay, so that's going to take a little bit more work. Once again, I'll just write it over here so I can refer to it. And again, some of you might not know exactly how to take it to the 3rd power, because I know some of you have the calculators like this one that are a little different, but if you're used to how they work, they can be nice. So here's how I would do it if I was looking on here. First, I would get rid of that. Whenever I do fractions on here, I just put parentheses around it, and then I just say 4 divided by 3. That's 4/3. And then the calculator looks at it as a number if you put it in parentheses like that, which is what we want it to do. And then pi. And now what I would do is once again start parentheses and then do 0.75. Now there is actually a 3rd power on this calculator somewhere, but it takes way too long to get there, and sometimes you're not going to remember. There's a quicker way to take some number to any power you want. The caret key, which is right here, happens to be right with pi, which is why it is often referred to by me as the food key. And then you have to take it to the 3rd power. Okay. For those of you that do not have a caret key, you probably have a y to the x button or something like that. But I believe the other TI-30s, the smaller ones, do have the caret key off to the left. Okay. Okay. So we do this. Ooh, well, that's not very much now, is it? Are you surprised by that number? Well, let's round, where do you want to round this one? To, you want to go just tenths, keep it the same, or what do you want to do? Oh, did we go out further on the other one? So let's go out far on this one too. We want to, what, 3 decimal places on the other one? So let's go 1.767. Okay, so this is 1.767, and a label would be? Yeah, very good, because here's your inches, which you have cubed. So you're telling me if I take 10.125 and subtract 1.767, that's how much empty space there's going to be? That really doesn't make sense, does it? How come this isn't right? We did all the math correctly. We used the calculator. Yeah, that's only 1 golf ball, so we have to take it times 3. Very good. Again, taking times 3 is not going to affect our label. It's still going to be inches cubed, but then we're going to get a little bit closer to what it should be. And so 5.3, is that what you get? 5.30, okay, and that is inches cubed. Again, is 5.3 your answer? No. 10.125 your answer? No. Take 10.125, which is all the empty space, and basically take away how much the golf balls are covering, and then you will be left with your answer. So take 10.125. So 10.125, which is cubic inches, and subtract 5.3, which is cubic inches, and that's a cube, there you go. And I think most of you realize that's going to be cubic inches. Again, you can do it here, but I start putting X's in there and strange things start happening. And what do you get? What is it? 4.825? So almost 50-50, right? Golf balls versus empty space. Do you think that's believable? Well, much more believable than it being 9 cubic inches of empty space, right? That we would have gotten the other way. Okay. So I think that's very believable. So any questions? The only thing I just want to review with you quick, just so you remember it, is a great circle is, if you're in a sphere, a great circle is any circle that would go around the sphere that would also have the center of the sphere as the center of the circle. You see here, basically, if you want to think of it as longitude, all of these longitude are great circles, but there is only one latitude if you want to talk about it that way. Only one latitude that is a great circle, the equator. Okay, because if you go around like this, you're saying that the center of the sphere is also the center of that circle. If I come up here and get one of the tropics, well, that's a little high, but that's not a great circle. Okay, because the center of that circle is not the center of the sphere. And so keep that in mind. That's what a great circle is. And let's face it, isn't that pretty much the biggest circle you can make around this sphere? Is kind of how you could look at that. Because you could go on a diagonal. They don't have to be this way as long as the center of the circle, center of the sphere. Questions? I don't know. Just to show you what it would look like with outlines on it. I don't know.